Newton and most of his contemporaries viewed light in the form of particles. According to Newton, light was in the form of small spheres or particles. In Newton's words, particles deviate after colliding with some objects, but pass through others. This behavior follows Newton's laws of mechanics and is known as the particle theory of light. Light only moves in a straight line, so it was natural for Newton to consider light as very small particles emitted from a light source and reflected off various objects. However, a group of physicists, including Huygens, decided to complicate the model. This group stated that geometric light could not explain phenomena like reflection or interference. On the other hand, the wave theory of light cannot explain why light emits photons when it strikes metal. This phenomenon is called the photoelectric effect and was discovered in the late 19th century. In the following comma, we will briefly present the views of various scientists on the nature of light. Newton: light is a particle. Light is made up of very small particles called photons, which have an extremely small mass. These particles are completely elastic. These particles are emitted from bright light sources such as the sun, candles, electric lamps, and so on. These very small particles always spread in a straight line and in all directions. Every moving particle carries kinetic energy. These small particles move at a very high speed. These particles move faster in denser environments compared to more diluted ones. However, it has been proven that this part of his theory is incorrect. We know that light moves faster in more diluted environments compared to denser ones. When particles hit the cornea of the eye, a person sees a reflection of the object. These small particles can have different sizes. It is these different sizes that create different colors. Mistakes in Newton's particle theory of light. Newton assumed that light moves faster in a denser medium compared to a rarer medium. It has been proven that this assumption is incorrect. The assumption that different colors of light are due to the varying sizes of its small particles has no scientific basis. Newton assumed that the reflection of light was due to the repulsion between the reflective surface and small particles. Similarly, the refraction of light was due to the attraction between small particles and the refractive surface. Therefore, an environment can repel or attract light particles. However, it was later proven that this statement was incorrect. We know that light, upon striking glass, simultaneously undergoes refraction and reflection. How can glass simultaneously attract and repel light particles? The particle theory of light is inadequate in explaining the phenomena of refraction, interference, and polarization of light. Newton discovered that when sunlight strikes a prism, it splits into its constituent components with different frequencies. Nevertheless, he believed that light is a particle because the shadows formed by light have distinct and sharp edges. Grimaldi and Huygens: light is a wave. The wave theory of light states that light has a wave-like nature. This theory was proposed during Newton's time. In 1665, Francesco Maria Grimaldi discovered the phenomenon of light diffraction. He also stated that light has properties similar to waves. After him, in 1678, the Dutch physicist Huygens developed the wave theory of light and named it Huygens' principle. Fresnel and Young: light is undoubtedly a wave. 100 years after Newton, the French physicist Augustin-Jean Fresnel stated that light waves have very small wavelengths. He mathematically proved the phenomenon of light interference. Additionally, in 1815, he established the physical laws of reflection and refraction of light. He hypothesized that space is filled with a substance called ether, as a wave requires a medium to propagate. In 1817, the English physicist Thomas Young calculated the wavelength of light using the wave interference pattern. He found that the wavelength of light is 1 micrometer. At that time, the particle theory of light was declared obsolete and replaced by the wave theory of light. Maxwell: light is an electromagnetic wave. The next theory was proposed by the Scottish physicist James Clerk Maxwell. In 1864, he predicted the existence of electromagnetic waves. According to his theory, the wave has electromagnetic properties. The existence of electromagnetic waves had not been confirmed before him. Until that time, the magnetic field produced by a magnet was assumed to be unrelated to the electric field between the parallel plates of a capacitor. In 1861, Maxwell presented his 4 equations that showed the electric field and the magnetic field are interconnected. These equations shifted the focus of research on light from visible light to the concept of electromagnetic waves, as visible light had been the center of attention until then. Einstein: light is still a particle. The particle theory of light was completely forgotten until the 19th century, when Einstein revived it. Now, the wave-particle duality of light is fully proven, and thus, the explanation of light phenomena has evolved from electromagnetic theory to quantum mechanics. One of the weaknesses of the particle and wave theory of light was its inability to explain the photoelectric effect. Einstein proposed the quantum theory of light to explain this effect. He believed that light has a particle nature. These particles are called photons. A stream of photons forms a wave. Einstein's quantum theory of light states that the energy of light depends on its oscillation frequency. Einstein stated that the energy of a photon is equal to the product of Planck's constant in the oscillation frequency. The number of photons determines the intensity of light. The various properties of light, which is a type of electromagnetic field, are due to the behavior of very small particles called photons. Photons are invisible to the eye. Thanks for watching the video, and don't forget to subscribe.